Welcome to the trials and tribulations of my 8-bit breadboard computer build. Now, here is a recap of the issues that I've been facing, such as rewiring the ALU and the RAM to get it to function correctly, my unstable adapter, and needing some replacements for the 7 segments and the dip switches. Now, for Kit 3 and Kit 4, I needed some of those replacement parts, but I went ahead and also ordered some dip switch extensions to see if it would help secure the switches that originally came with Kit 2, but it didn't. So I just went ahead and tested out the new switches that I ordered from Amazon, which I'll go ahead and put the link in the description below. And it looks like they're working. So that's great news, and they are needed for Kit 3 and 4. So now that I know that these new dip switches from Amazon are working, I can go ahead and move forward and just test out the new 7-segment displays that I've ordered. In the next clip, we'll go ahead and test those out. Once again, we're happy the dip switches are working for Kit 3 and 4. Now we're going to go ahead and test out the 7-segment displays that I also ordered from Amazon, which will also be in the description below. Now, I'm going to go ahead and give a nice close-up of the display here that I'm going to be testing out. And we'll possibly use, so there's some information on it, like the model number or the type of display it is for the certain pinout that we have. I tried to find the exact one that was in the kit. So now moving forward, we're just going to go ahead and clip it into the breadboard and place some resistors on the 3rd pin of the display. And we'll set that on high. And then we'll go ahead and test the segments and make sure each segment is lighting up and working correctly. The resistor I'm using in this clip is a blue resistor, and it's one that I ordered off of Amazon just to make sure I had enough extra components in case anything broke or, was damaged. That way I could have backups so I can continue with the construction of the build. So now we're just going to power up the breadboard and test out the segments of the display to make sure that they're working correctly. As mentioned, the ones that came with the kit were not working. I use sometimes an LED to just make sure quickly that there is power to my breadboard. But here you can already see I'm starting to test things out, and it is lighting up. So far so good. It looks like we haven't ran into anything not lighting up. So we plugged in that resistor over there to the positive side, the positive charge. 5 volts, and we have this wire that I'm using is hooked up to the low negative side, but the 7 segments are working, so that's great. We can move on. We can go ahead and just troubleshoot the ALU now that we have the replacements and they're working correctly. So with the ALU, I'm just gonna have to go ahead and troubleshoot it. What essentially is happening is the ALU uses the A and B register, and when I started to put them together with the clock, there was no power. It didn't seem like it was functioning. So here you see I'm using an oscillator to try and test out the voltage, but I decided to just break down the kit break down that build. So we start powering up everything individually. So the clock is working fine. When we get to the A register, it's not functioning properly as we saw before. So I'm just going to go ahead and troubleshoot that as well. The register could be storing all zeros, but I'm just going to rebuild it in case something is not wired correctly. That also helps with getting to know the architecture and the pinouts and how everything's functioning. But sometimes the LED also might be touching each other, and that can cause some friction messing with the output. For example, if an LED is supposed to be displaying a 1 but is touching another LED, it might display a 0 due to that interference. So I'm gonna have to do something about that. I saw Ben Eater mentioned adding some insulation to the legs of the LEDs. So I guess we're gonna go ahead and add some little pants. So we can go ahead and prevent that interference and provide some insulation. So here we have the little pants that I made out of wire stripping to insulate the legs, and we are going to go ahead and proceed to test it out. I have redone the register many times, so I pretty much memorized the entire architecture and setup. on the left side of the breadboard or of the build here, we have everything that's going to be going on to the LEDs, displaying an output, and on the right side, that's what's going to be going on to the bus. So this part of the kit really helps you understand how data moves throughout the computer to different sections using the bus, while having this two-way channel of communication, reading or writing data. So here we will have the LEDs with their insulation that, or the insulation pants that we've added to reduce friction and prevent interference, which was an issue that we've noticed before. We have the clock hooked up here, and I went ahead and added some labeling just to make it a bit easier to go through testing faster. We have the load signal set to high as a default, so nothing's happening on the high. And we have enable set to high, so when it's on low, that's when we're loading data and displaying data onto the bus. Now we can go ahead and proceed with testing register A. So again, to recap, I was beginning to troubleshoot the ALU, and when I started to put the other builds together, there was a problem with the power, which could be due to my adapter, so I'll have to find a solution for a more reliable source of power or a way to evenly disperse power, but we are just going to go ahead and check. I've just been checking everything 2 times over, 3 times over, via the video tutorials, the schematics, the chip pinout, etc. I've built the register numerous times, so I've just decided to make it easier with labels and how certain jump wires function. For example, we have the cable for loading, another for enabling, which, defaults as high, and when we set it to low, that's when we're loading data, or we can enable data onto the bus. So we've hooked up the bus over here on the left that you can see with the yellow LEDs. Kit 2 really helps with the understanding for the need for the bus and how it helps with moving data throughout the computer and into different areas and registers, ultimately for whatever programs are running, or, just essentially how significant that role is that the bus has. So we've just been messing around and troubleshooting our registers, which have been connected to the clock from Kit 1, where I've also tried to add some labeling and the green wire on the A register just to reset the register. In the next clip, we will go ahead and hook things up to power. So here we have the registers, and I'm just showing that these LEDs here are possibly they don't work because when I proceed to test it, and let's say if I set that LED to ground, then it shows up on my register as that bit has been set to 0. If I take it out, see, without messing up anything, there you go, it goes back to all ones. So if I decide to do a different one, let me see. There we go. Do this one, do that one. So it looks like it's doing what the bus and the register are communicating. It's just those LEDs that are not working on my end, unfortunately. But it's okay. It's still a good sign. Good sign it's working. It's communicating. These LEDs just don't work to actually show this. But it's all right. We'll move on. So I swapped out some LEDs from the bus to try and test it out to see what's going on. This is a small issue, so as I mentioned, do get some backup components like the LEDs because they do burn out and they do explode, so also get some safety glasses to protect your eyes. But so far the communication with the bus is working when I am trying to set certain data, but we just need some LEDs that do work so we can make sure that we're able to display it onto the bus as well. For now, we're just going to move forward with building the B register, the bus, the LEDs. Like I mentioned, that's a very small issue, and we can figure that out as we go along. So here we can see the B register looks like it's working. Just like the A register, I built it exactly the same. Besides the small issue with the LEDs on the bus, it looks like the B register is working correctly. So that's good news. I'm just seeing if at least I can manipulate the output, which it looks like I can if I do want to enable or load data, specific output into the to the register here. But it looks good, so I just hope that when I do put all the parts together that they can function and that I can actually test out the A and the B register with the bus and with the ALU and with the clock incorporated, and just that everything powers up correctly and can allow that testing to proceed. So here are just some shots as I build the ALU in between the A and B register. In my previous videos, I go over the chips that we're using and how they work, but here I've set up everything a bit swiftly. I've added the pans to the LEDs like we've done in the previous video. So here are some photos of me testing out this attempt to troubleshoot the ALU in my registers, which it doesn't look like it's working. So it looks like we have to go back to the drawing board, back to brainstorming what we can potentially do to find solution. So back to the drawing board, or essentially just trying to redesign this kit in a different way. So I've added extra breadboards to the ALU, to the register to spread things out. You can see my adapter here is pretty chunky, and this is the adapter, like the outlet for France. And just to show you how I have to shake it just so that I can get power, and how fast it goes off. So that's definitely a challenge. I'll have to invest in a new adapter that can provide reliable power. But I start off by testing off my clock, making sure everything's working appropriately on that, and then trying to test out the registers that we've added on. So essentially I have added the insulation to the LEDs. I have redesigned it, like I've added blue LEDs instead of LEDs to the B register. I've color coded some of the wires just to help with better organization when it comes to like the schematics and following the process of it all. So I'm just going to go ahead and start testing each piece on its own by itself and add it gradually as we've seen in Ben Eater's YouTube videos. So here is my clock. I've already tested it a bit in the previous video, but I'm going to go ahead and test it again. I'm just using this to kind of dust off the dust that accumulates on it. If you don't keep it covered up, it will get a bit dusty. But like I said, I'm going to go ahead and test out my clock, and then we're going to test it with these registers that I've redone. I've spread out the LEDs a little bit. I've also changed the colors to be a bit more distinct, just so that it's better for me following the schematic and just having to reference back and forth. I think the color coding is a lot easier and keeps you organized. So we're going to test it out in the next video. So I'm going to go ahead and end this video now that we have tested out the replacement components ordered from Amazon and they are working, and now we can definitely move on to tackling on the bigger issues, which we'll go ahead and continue in the next video with testing out the new design of Kit 2, seeing if it works, seeing if we have to go back to the drawing board one more time and do it again, and moving on and tackling on issues with the RAM and building Kit 4. Thank you so much for watching. Until next time.